Hi everyone, I've had a request to solve question 3B from the 2019 level 2 mechanics paper, the NCEA paper, and so I'll just read the question. I've written some information here just to make it faster. So this is to do with a game, and when hitting the stationary ball for the penalty corner, Nicole hits with a stick velocity of 18 meters per second. After hitting the ball, the stick continues forward, that means it's in the same direction, at 12 meters per second. The mass of the stick is 600 grams and the mass of the ball is 160 grams. We've got to find out the velocity of the ball and what assumptions do we make in our calculation. Now, the thing is, the ball's stationary to start with, okay? So what I've done is I've just written some information separately for the stick and the ball. So the initial velocity of the stick is 18 meters per second and it's going forward. The final velocity, the stick carries on moving forward after moving the ball, after hitting the ball. So that's 12 meters per second. The mass of the stick is 600 grams. We always have to change the mass to kilograms. So that makes it 0.600 kilograms. Now the ball, it was a stationary ball, so the initial velocity is 0, but after being hit with a stick, it will have some velocity, which we have to find out. And the mass of the ball is 0.160 kilograms. Now, this sort of a question has many ways that we can solve it, and the way that I'm going to do is to do with conservation of the change in momentum. So the assumption I'm making is that there is no external force and this is a closed system which includes just the stick and the ball. So in the way that I'm doing it is both the ball and the stick are going to experience a change in momentum. Now the change in momentum of the stick will be exactly equal to the change in momentum of the ball, but it will be in the opposite direction. Okay, so that's the whole thing with conservation of momentum. So the total momentum stays the same the whole time. So the change in momentum of the stick, or I better use black. I'll color code the stick with black and I'll do the ball with blue. Okay, so change in momentum of the stick is mass times change in velocity, which is final velocity minus initial velocity. Okay, so the change in momentum of the stick, the mass is 0.600. The final velocity is 12 in this direction minus 18 in the same direction. So when you subtract vectors, you always add the opposite. That's what you do. And this is just a mark on the board. It's not anything I've put. So you end up with change in momentum of the stick is 0.600 multiplied by 12 forwards, 18 backwards is 18 minus 12 is 6, 6 in this direction. And so that works out to 6 times 0.6 is 3.6 kilogram meters per second, 3.60 to make it to 3 significant figures. So that's a change in momentum of the stick, and that's in this direction. Okay. Now let's look for the change in momentum of the ball. Is going to be exactly the same but in the opposite direction. So the change in momentum of the ball will also be 3.60 kilogram meters per second this way. So 3.60 that way is equal to the mass of the ball times the change in velocity of the ball. Since the initial velocity was 0, the change in velocity is the final velocity. So 3.60 equals the mass of the ball is 1.60 times v, which is the velocity of the ball, or v is 3.60 divided by 0.160. And what do we get? So on my calculator, I just go 3.60 divided by 0.160 and I get 22.5, and that is So V, speed of the ball, is 22.5 meters per second in this direction. So that's the answer to question 3B from the Level 2 NCEA Mechanics 2019 paper.